Adam Tank is with a technology company called Transcend in Kansas City. Where are you? You're in
I'm in Kansas City. That's right.
Yeah.
Yep.
By the way, the Midwest of the United States has got some rocking startups in the water sector. Seriously, it's like I no flyover when it comes to leading the charge in water innovation there. Adam and his team arose out of Organica, which was essentially a consultancy, and they built this tool. And the tool that was going to help them to do their work, and the tool is so flippin' amazing that they decided to spin out the tool as a separate company. So that's my introduction. Adam, please take it away.
All right, Peter, thank you for the intro. It's good to see familiar faces and, of course, new ones as well. What I don't know, though, is why everyone is interested in joining the session. So if you want or you don't mind putting it in the chat and explaining what interests you specifically about the topic, that way it can be more conversational than me talking at you. My biggest fear in life is when someone starts a presentation, they go, feel free to interrupt, let's make this a conversation. And then they show you slides for an hour and you don't actually get to talk. So let's make sure that that doesn't happen. And please make sure if you have any questions, put them in the chat, raise your hand, stop me. I'm not going to be offended. This really is meant to be an exploration. So, not knowing all of your backgrounds and not knowing what specifically interested you about this topic, I will go ahead and share my screen. So as it's listed in the agenda, today we're going to talk about how artificial intelligence can and maybe should be applied to the role of wastewater and wastewater engineers, specifically for the design of water and wastewater treatment plants. So this isn't about control of the plants. It's not about the data that something like a digital twin might create. It's not about the sensorization of the plants or the treatment processes. This is about when you are thinking about expanding a wastewater treatment plant or building a new one or consolidating multiple plants or thinking about conversion of one treatment technology to another, how can artificial intelligence be applied to that process and make it more efficient? And I'll give you a little teaser. Computers are really impressive and software is really impressive where it's gotten. And I'll show you some examples of that. But computers aren't human and they aren't necessarily creative. So when I talk to engineers about the role of AI in design, the first question I get is usually, how do I know that this works? Can I trust the software to do the design? The second one is, what happens to my job? So we can talk about those things today, and we might get there eventually. But for now, I want to go into a couple slides really quick to sort of set the stage.
Adam,
yes.
Quick comment here. I think many people that use the term AI don't know what it means. Can you define it in this context, please?
So this is artificial intelligence applied to the conceptual design of a wastewater treatment plant. So
I think Zahi is asking, what do you mean by AI? Like,
yes.
Are you talking about machine learning? Are you talking about, algorithm-based AI? What do you mean here?
This is algorithm-based artificial intelligence utilized in generative design for wastewater treatment plant applications. Does that help or not? Hurt?
Oh, Zahi, do you know Zahi?
I have no problem. I think that we need to have a baseline that everybody knows exactly what we are talking about.
Yeah.
So
you may, Adam, I don't know if you're
yes.
going to get to this, but you might illustrate or answer Zahi's question if you get to a moment, I don't know if you've prepared that for this presentation, where you kind of give us a glimpse into a specific case or section of design where you begin to see what boundary conditions do we set up for the optimization? What are the tools and pathways that we're using to derive that optimization, et cetera? So that, are you gonna get into those weeds here?
We won't go that deep, but I will give you a specific use case of AI as it's applied to design.
Yeah.
So I will say at a high level, computers are smart enough to not only select and size various units inside of a wastewater treatment plant based on a set of parameters you give it, but it's also smart enough to work through loops that then optimize the design to lay out a wastewater treatment plant and all of the associated equipment in an optimal fashion.
And given global boundary conditions on things like footprint, et cetera, et cetera.
That's right.
Yeah. Watch, Zahi, watch. By the way, you guys don't know each other? Do you guys know each other?
No.
Oh, you guys, okay, I sense a love fest coming on. Zahi Kath is a professor at Colorado School of Mines and truly one of the foremost research people working on practical issues associated with water treatment and wastewater treatment design. He actually runs his own water treatment facility, treating several dormitories on the Colorado School of Mines campus. And you'll learn about Adam's company, Zahi, shortly. But Zahi is a core member of the NAWI team.
Excellent. Very cool. All right. So keep in mind, I'm going to be a little bit biased here because this is what we do every single day. But we believe as wastewater treatment engineers turned computer programmers, that the world at large is at an inflection point. And that inflection point is this, that manual tasks performed by humans to automated processes powered by machines and computers is transforming entire industries. And water seems to be like the last one to come around the curve. As many of you know that are in the water industry, we typically like to lag for one reason or another, but it's happening. And it's not, it's not just one segment or one industry. It's not just manufacturing. It's not just data and artificial intelligence is applied to scouring through data and drawing, conclusions. It's in healthcare. It's in it's in HR. It's in transportation. It's in finance. It's in all these different industries. No one is immune to this shift. Everyone is changing. And there's always some really interesting quotes. So one of these ones from Mark Cuban, he says, artificial intelligence, deep learning, machine learning, whatever you're doing, if you don't understand it, learn it, because otherwise you're going to be a dinosaur within 3 years. And some people would argue that the water industry already is a dinosaur. So we're going to try to pull the water industry into the 21st century and get us out of the prehistoric era. In terms of raw numbers, so 47 billion expected spend on AI in 2021, 85% of customer calls handled without a human touch point last year, over $10 billion in VC deployed AI startups, and then number of startups tracked globally. This is last year's data, but 3,000 emerging startups every single year. So there's a ton of momentum in industry relative to artificial intelligence. What also, though, is really interesting is that this sort of extinction in these dinosaurs, they're disappearing rapidly. So a stat that always astounds me is this one, that over half of Fortune 500 companies have disappeared in the past 15 years. Over half in just 15 years. And 40% of today's Fortune 500 are at risk of disappearing within the next 10. Companies that aren't willing to shift and transform with the power of technology are going by the wayside. They literally are becoming extinct dinosaurs. And I believe that the common thread is that they're failing to reinvent themselves, adapt, and deliver on customer expectations. There's the high level. Now let's bring it to water for a second. I believe that the water industry, but more specifically, design engineering, so either done by consultants, by equipment manufacturers, or by folks in-house at utilities, is the next big industry that will be transformed by radical advances in technology. It's happening in roads, it's happening in transportation, it's happened in oil and gas, it's happened in bridges, it's happened in all sorts of other built infrastructure. And we're now at the point where it's coming to water. And everyone should be aware of it. In terms of this transformation, this is a picture of Wall Street back in the heyday. Tons of folks on the floor screaming at each other, throwing around paper slips. You walk into a brokerage today, or you walk onto a trading floor, all digital. I mean, billions, if not trillions of dollars exchanged virtually. Operating room, dozens of people working on a patient. You now have systems like the Da Vinci robot. Surgeon, nurse, robot. Faster, better, cheaper, typically better outcomes for the patient. Take your standard engineering consulting firm back in the 50s or 60s. This is what you would have walked into. Giant rooms of people hovering over drafting boards, creating designs on pen and paper. This has already changed. We now have computers, computer-aided drafting, CAD programs that help engineers do these designs faster, better, cheaper. But it has yet to be automated until now. So I'll show you an example of that automation right now. This is a computer designing a P&ID, bespoke. So based on a limited set of inputs, influent and effluent characteristics, treatment technology, computers can actually design a P&ID in seconds rather than the hours or days it would have taken previously to do this work. But it's not just CAD programs or P&ID. It's things like site layouts and BIM models. It's process flow diagrams and process schemes. It's 2 and 3D views that can be done literally in minutes by computers, bespoke. These aren't templated. They aren't pulled from past projects. These are individual designs specific to a site, specific to given influent and effluent characteristics that can be designed entirely by software. So the question I always like to ask myself, and this is my last slide, is why is this important? What does this mean for the industry? And I'm looking at this in 3 buckets, and I would assume that most of you fit into one of these 3 buckets, and the fourth, I suppose, would be academic. So first bucket, engineering consulting firms. They're servicing water utilities. They're providing this type of design work and alternatives evaluation. Obviously, their lives can be changed through advances in automation. Second, equipment manufacturers. So the Karen Sorbers of the world who have to hire an army of application engineers to create proposals for her treatment technology. Too many of these companies can't afford to do that. They can't afford to hire 10 application engineers to put proposals out the door that then they get feedback on. They have to change the design. They have to start all the way back over it, and the list goes on. It's a massive pain in the ass for many engineering technology companies. And the third bucket are the utilities themselves. So the ones that are big enough to have in-house engineering teams can utilize the power of software and create designs and do alternatives evaluations that typically would cost $50,000, $100,000, $250,000 in billable engineering spend, either in advance of an RFP or when the RFP comes out. When we started this company and when we started on this journey, we interviewed over 300 water and wastewater engineers in the US. And here's what they told us. I don't have enough time to properly evaluate all the options for a specific project. When bidding on a project, pre-contracting phase, I don't have enough hours to do the preliminary engineering work. My clients value speed when producing designs. It would be valuable for my firm if I spent less time doing design work and more on other business activities like marketing, site visits, client communication, etc. My clients will pay me to provide more detail in the earliest stages of a project. My firm doesn't have enough time to bid on all the projects it would like. The shift towards automation is coming. The engineers are asking for it. The utilities want the outcome. The equipment manufacturers need more time to do the detailed work in their proposals and be out in the field with their clients. And that's what excites me about this world of artificial intelligence as applied to water and wastewater design engineering. I'm going to open it up for conversation, and I'll check the chat for any questions.
Okay,
Here's
I'm
my
gonna
contact
go
info.
right off the bat.
Yeah,
I'm
go ahead, Peter.
gonna come at you with a bunch of stuff. So this so the group you are speaking to are a combination of, you know, some people, industry people who are in the water sector, some technology people, and some researchers. So I guess one thing I think from a research standpoint is let's kind of zoom out and say this general approach to optimizing design. You started in the wastewater sector, I presume mostly because Organica was there. What would be necessary for you to essentially build the same capability into a broader set of water treatment processes like desalters and desalinators? Can you give us a sense for how much input and stuff you needed before this package was ready for wastewater, and how much more stuff and input you'd need before we could start looking at optimized designs in desalters?
The short answer is that if the data exists around a given process unit or technology, and there are rules that can be applied for how that technology is designed, sized, put on a physical site, then we bake those rules into the software and you'll get a design for that particular process unit. So we're, as an example, later this year, we're moving into drinking water. So the treatment of surface water for potable water purposes. And all we're doing is saying, hey, we have this engine that can select and size equipment, that can design the mechanical engineering, that can do the electrical work, that can do the civil work. What are the rules applied to different process units specific to water? Let's say RO, or even forward osmosis, or UF. What do those look like in terms of rules? We'll bake them into the software, and it will generate the outputs appropriately.
Okay. So you know that. So I'm going to talk. I'm going to call on you, Karen, momentarily. Don't worry. I've got my eyes on you. So you know that NAWI is building something called Proteus Lib, which is a library of unit process models. And we have a team stood up led by David Miller at the National Energy Technology Laboratory using a platform that's already been well vetted for doing unit process and system process optimization. They're focusing on the unit process phenomenology, okay? They don't solve for hydraulics. I think you guys do. I don't think they solve necessarily for some of the other factors that go into kind of sizing a plant. But it seems like this unit, you need unit processes. So let me just ask, in the package now, do you have a model for an MBR and a well-characterized MBR?
We do.
Okay. Do you have models for different manufacturers' MBRs, or is it basically just a unit MBR box that's general enough that everybody kind of fits?
Both.
Okay. If I was a manufacturer of an MBR, what would I want to do, Adam? Would I want to kind of partner with you to make sure that Transcend has a nice, strong unit process model branded of mine so that you could compare me to others?
Wow.
Our current MBR clients, and we work with 3 of the top 10 global MBR suppliers, and we're going to have a big announcement coming out next week about another one. They use it twofold. So one is my commercial teams are trying to sell MBR, when they go to develop a proposal, they have to lean on my in-house engineers to do the engineering and design work for those preliminary proposals to just get my foot in the door.
That's right.
So they're utilizing our software to automate the preliminary engineering of the MBR, and then also the documentation for the proposal. So the design basis, the technical description, the drawings, anything that goes into that proposal can be fully automated with software.
Okay. Now, on the one hand, that's a help to them individually responding to bid opportunities as they come up. Now, I'm sitting there, say, I don't know, in Southern California, I don't know, I'm thinking about a water reclamation facility, crossing my arms and looking at the MBR. Could I use Transcend to essentially virtually trial all the manufacturers against each other?
The ones that allow us to put their design rules into the software, from a generic point of view, yes. And today we have Suez 500D, we have I believe we have the Kubota line, and then we have Memstar. So those are the three that you can access from a generic rules point of view today in the software. And you could run 3 different designs, get all 3 different outputs.
So strictly speaking, maybe they all are kind of almost interchangeable. Maybe their performance are, kind of in the same envelope, or maybe they're not. In which case you could also say, well, the Suez unit's 30% higher, but I can now do a whole system analysis and arrive at not what the salesperson told me, but an actual NPV of what that improvement performance step is in the MBR unit across the entire project.
That's
right.
right.
So now moving into, let's say I'm an early stage company with a novel process, I don't know, and maybe I'm sitting there thinking, I want you, Adam, to plug my module in, and especially in these, like maybe leachate, I don't know, maybe leachate. And I want you to show clients, or I want to be able to partner with you to show clients what my improvement is. Could you do that?
We can, and we have, and we do.
Can I take over?
Sure, Karen, off to you, Karen.
So this is really exciting to hear this. Let me just ask you, so let me tell you a little bit. So we've spent the last year and a half with a nuclear engineering firm designing our unit that's going to EPA for testing in a few months. And it has been a very difficult process, very virtual. We've got PhDs in Maine, Ohio, we've got Virginia Tech, we've got them in wherever, and they're all doing this collaboration. They do the P&ID, I don't know how he's doing it, and we beat the heck out of it. And then our EPA Chem-E program manager has modeled the influences of the heat exchangers. So at the heat exchanger level, pumps, right, goes in as and goes out as. They're looking at temperature, pressure drop, and airflow, and they're putting those into this Chem-E, ChemCAD system to model anticipated gallons per day. Okay, now that's not the design with the footprint and the subsystem performance measures and all that. That's over in the P&ID, and then they're doing CAD software design engineering, right? So I'm trying to figure out what this software would do to truncate that, because I'm raising money now to design and build a leachate pilot to go into the field. And it's going to be small and untransportable. And the idea of spending another year and a half with those guys doing this once makes me want to quit. Can you help me? What's your business model? Is that something that we can work together on? How is that?
Yeah, we should definitely talk. We should definitely talk. So because we are a team of wastewater engineers first that then got into computer programming, a lot of that heavy lift on the modeling and the drawings and the automation of OpEx lists and load lists and all that other stuff is taken care of by our team. So all the heavy lifting is our burden, if you will.
Okay, lovebirds, go off and deal with that later. I want to bring Warren in here. Warren, you are in an agency of scale. What is your question?
Well, I was thinking about how a water agency like Metropolitan would use something like this. We're one of those agencies that's large enough. We have our own treatment plant design team, and they're constantly reworking our treatment plants, upgrading them, in some cases taking them out of service with the growth and advance. But I was wondering, when you said optimization, optimizing what? Is it optimizing costs? Is it optimizing treatment performance? And then I was thinking, so let's say, and the second part of that question is, let's say we put out an RFP and all of our, large engineering design consultants are using your software. Are we going to get like 10 proposals with the same design layout because it's all been optimized with the same parameters and using the same technologies? How do you get new technologies in there to get innovation forward, I guess?
Yep. So today we sell to two sort of entities primarily. And I'll say primarily because there's a third bucket that we need to talk about. And you, Warren, specifically, and anyone else that's on the utility side need to talk about. So the first entity are those equipment manufacturers, the Cairns of the world, the MBR manufacturers, the activated sludge folks, the pumps, the blowers, the DAFs, the whatevers, those folks. Then we have the engineering consulting firms. They use our software to be more cost competitive. So responding to an RFP, you're asking them, hey, how many billable hours are you going to charge us at what rate? And they can say, hey, we're going to cut that in half in hopes that they can win the detailed design work or whatever the bid is, be it design build, whatever that looks like for you guys. That's what they're hoping to use it for. And additionally, evaluating multiple options early on. Those are our two big ones. We haven't gone direct to utilities because we worry that the engineering firms are going to be upset with us, probably rightfully so. We're a software business. We're not a consultancy. We're not an engineering firm. We want to help those guys. But I mentioned this third bucket. So this third bucket is United Utilities. Largest water utility in the United Kingdom. Invited us to be a part of their innovation lab this year. And what they are using it for is to do all of that early conceptual alternatives evaluation for every single one of their wastewater treatment works and saying, hey, we're either not meeting regulatory requirements or our effluent limits or discharge limits, we're not meeting them. Do we need to upgrade the plant? Do we need to demolish it? Do we need to build a new one? Do we need to convert from activated sludge to MBR? There's a whole series of questions they're asking themselves, and they're using our software to do that conceptually before they put it out to bid for an engineering firm. So that's something that they would have put out to bid previously, or they would have spent so much time in-house. They've got 450 wastewater treatment plants. They can only tackle 100 in a given year. Now they can tackle all 400 or 450. So that's how an entity like that is using the software today. To your question about if 10 different consulting firms are using the software, you're going to get the 10 similar outputs. The answer is no. And the reason the answer is no is because when we work with consulting firms, we spend days and days in the upfront stages having our process engineers sit with their process engineers, our mechanical engineers sit with their mechanical engineers. And we say, how do you design a wastewater treatment plant? When you're thinking through the rules and logic and your expertise, what's going on in your head? What are the ratios that you're using? How do you think about sizing different rooms? How do you think about laying the facilities out? Those all become rules in the software. So I can tell you today, I'm grinning because there's two different engineering firms in the States using our software for similar applications around MBR, and the designs couldn't be more different. One engineering firm says, hey, I want to have shared walls with my clarifiers. The other one says, hey, I want to have this much space in between each clarifier, and I also want to have this much space from a road to a building. They look completely different.
So can I say that there's a natural kind of tendency to say, oh boy, the consulting engineer's goose is cooked here. But what you've actually done is you've moved the consulting engineer back into what I call the creative class, where they begin to think about things that are different than just the layout of the piping. They begin to say they have the ability now to discuss and consider ergonomics. They have an ability to discuss issues of aesthetic or even just workflow, right? Which are less capturable in a computer optimization, but more a function of taste and style. So maybe our consulting engineers will graduate from being just, kind of pipe weenies and, that sort of thing, and move into the more creative style of architecture associated with considering the broader implications of one design aesthetic or one design set of priorities versus another set of design priorities. That'd be very interesting.
Warren, my hope would be that if your in-house engineers are using the software, they're able to evaluate multiple options for a given treatment plant for multiple different factors. So it's not just, hey, we have an activated sludge plant and we're thinking about going to MBR, but also what if we check the box for MBBR or MABR or a fixed film membrane? What does that do to the facility in terms of footprint or OpEx or CapEx? Or in the UK, they're really interested in carbon calculations. So those are the types of outputs now that
tell me
engineers...
what your agency's priorities are, and I can give you a design that reflects those priorities.
That's right. That's right. And it's not based on, some project they did 15 years ago that sort of kind of looks similar and they're going to try to make it work for you.
Exactly.
It is a bespoke design specific to that site with those specific influent and effluent characteristics that is, like I said, created in hours.
Oh, by the way, and I want a line of alders and ash trees on the southern border. And I'm thinking about, be fun. But I want to kind of pronounce, this has been a very kind of industry focused thing. And Adam, I hope that you've got now 2 great follow-ups. So as far as NAWI is concerned, our job here is done. But I want us to turn our attention more to the R&D side of things, okay? Because I think you've still got on the line a bunch of, AI experts from the national labs. You have people who are engaged presently in Proteus Lib development. And I would say, I think that if there was a automation opportunity in the design of small scale desalters or something, I think that would be a very interesting project for us to consider together. So I'd invite anybody else who is on the line from the research community. You've been hearing us, sort of from the water, talk about this disruptive technology from the standpoint of the kind of industry. But where are the opportunities to further advance the capabilities of automated design? And what do you see as the key priorities, Adam? What do you guys need to kind of further expand the capability of this approach?
So the way that we think about it is, we'll call it water industry verticals. So right now, municipal wastewater is our bread and butter. We're rapidly moving into industrial wastewater. And to our conversations earlier, it's mainly about given process units. So if NAWI or others that are researching how a given process unit might function from a modeling perspective, we can tie that model into our software so that when the designs come out, they accurately depict what's happening from a process point of view.
Okay. You could also do sensitivity analysis, and you could then tell me, well, Peter, presently your module has an envelope of this. If you could, and that means that my variability in ultimate outcome is in this envelope. If you have tighter constraints, I can get more precise. The other thing is you could tell me if I improve my flux by X right in this unit process, you can give me the entire optimized downstream payoff. One of the other, and flipping this around, I want to open it up for other people momentarily, but flipping this around, can you talk to us about retrofits? Because of course it's nice to have a clean sheet of paper, but what is the utility of this approach if you were sitting there with, say, like a slow sand filter, and you're thinking about putting in NF or some other modularized pre-treatment step? Can you tell me how your software would help me in those considerations? And that's more on the water side than wastewater.
Yes, and I think it's probably easiest if I show you what that would look like. just from a visual point of view, because that's one of the biggest questions we get is like, fine, if you're developing a greenfield site, right, it's easy for software to just say, oh yeah, lay it out on a flat piece of land and everything is hunky-dory. But in reality, we know most sites are not greenfield. They have existing assets. It's been in operation for a long time, especially in North America. So what we would do in that case, again, I'm going to share my screen. So the difference between a conceptual, like we'll call it greenfield build versus a brownfield build is that you have to tell the software what's already in existence. In the absence of you telling the software what's there, it's going to assume, it's going to make an assumption. So let me give you a good example of this. So type in your site address, right? Warren MWD types in a site address, pulls up the wastewater treatment plant. And the goal of the user is to tell the software, hey, here's every building on site. Here's where we can and cannot build. Here's the boundaries of the site. And then here are the assets that are in each one of those buildings. So in this case, you've got the clarifiers, you might have a digester on site, you've got admin buildings, you've got all sorts of things, you've restricted zones, all of that, and you're able to detail that on site. So then what you do is if you were to say, okay, how does this reflect real world conditions? Well, Warren wants to upgrade his plant, and we know that this third treatment train hasn't been used in 10 years and isn't planning to be used. We can either repurpose it or just allow the software to do something else with it. So we knock it out, and that tells the software, hey, you now have this room or capacity to design, add a new process unit, replace a process unit, put a new building there. You're giving the software that set of parameters to do something new with it. So then when you have existing process units versus new process units, the software then creates basically a basic block flow diagram or process flow diagram, and it'll say, hey, does this accurately reflect what's going on site? Do you need to add some type of screen in between two different process units or two different buildings? You can do that. And basically, once you're done validating that the existing site accurately reflects what is currently in operation and what you want the new site to look like based on what the software's come up with or what your engineers have come up with and put in here, you submit the design. Does that make sense, Peter, visually? Does that answer the question?
It does.
Okay. All right.
It does. It also, to me, reveals a very valuable value proposition for existing utilities who might just, given the ability to do it quickly. I mean, people embark on a treatment plant upgrade begrudgingly and with enormous, breast beating of like, oh shit, here we go. And for me to be able to walk into my board and say, we've now done essentially an asset value analysis from the process side. And of these 12 plants, these two are absolutely ripe to increase value to us as an agency. And here's how we do it. To be able to do that economically and not spend $2 million with Black & Veatch or somebody to do it is transformational. It really helps guide people into better understanding of like, why am I putting up with this? Why am I putting up with a shitty clarifier? I don't need to do that any longer. And in fact, I think what I can predict what will happen, you'll do an analysis and people will say, I've been saying, the operators, I've been saying that for years. And then at last the operator will be like, thank God somebody listens to me in management because, now you have a tool that's clean. So thank you very much for that. I want to make sure, Jen Stokes-Drought had a question. I want to just suggest, Jen, that you unmute yourself. And Jen is our Deputy Topic Area Lead in data modeling and analysis. So of all the people who I was hoping might see the capability of this tool, Jen is certainly one of them. Jen, are you there and are you able to hear us? Good. Jen, ask your question, please.
Yeah, I absolutely see a lot of value to this tool, but I also, and this is endemic in the water system, that it's pretty siloed on. We're doing wastewater treatment here. And then when you think about expanding, you're like, well, now we're doing water treatment. But I think now he has this perspective of thinking about it as a circular water economy and trying to think somewhat about broader system impact. So my question, basically is, how do you see this tool or these types of tools fitting into that kind of framework? What are the benefits of sort of like trying to push people more into this circular thinking? That's not exactly what I wrote, but that is what I'm trying to get at. And what makes that, like, what's keeping you from doing that now? Why? Besides, I think it's obvious that data and institutional challenges would be potentially an issue, but from a technical standpoint, what do you see as the challenges?
Sure. I love that question, and it's one that we have been asked specifically in the UK, because they are I would argue they're 15, 20 years ahead of where we are in the States relative to circular economy, carbon, water energy nexus, right? All that type of stuff. And so there's two things I want to say on that. So the first is we have no plans to go into horizontal assets, meaning collection systems or distribution systems. We are squarely focused on everything inside the fence of the wastewater treatment plant. There are other companies out there, and I'm happy to recommend, that do some really cool work in the horizontal assets, and I push you to them all day. At some point, we may tie in literally at the fence line. We'll see what happens. But until that happens, we have no plans to do it. The way that the UK is thinking about, and specifically United Utilities, is from a holistic point of view, hey, maybe we should consider reuse here, either IPR or DPR. If we were going to do that, what process units or technologies would we need to implement on site to make that happen? And it's literally as simple as a checkbox, right? On your tertiary treatment, do you want some type of final polishing step that would then be able to have it be used for reuse? So do you have RO on the back end? What type of disinfection do you want? UV, right? Any of those other things, those just become a checkbox, and they become an assessment of the software to do that type of work or analysis in the front end. The other way they're thinking about it is, hey, we used to have 3 wastewater treatment plants that existed within, say, 20 miles of each other. If we consolidated those into one, what would that mean for building that new one in terms of the land footprint, the carbon calculations, the cost to continue operating 3 versus 1? So from that holistic perspective, that's another scenario or set of assessments that they're doing with the software. And then the last one is around natural systems integration. So we want to convert a wastewater treatment plant into reed beds or some type of natural ecosystem treatment technology. If we demolished our clarifiers and used that instead, what would that look like? What would it cost? What would the impact be on the energy, CapEx, OpEx, TODEX? That's another type of assessment that they're doing.
You know,
Can I
the
just
passive
follow up
system,
quickly?
sorry, Jen, I just want to make a note to
Yeah.
everybody. Passive systems are one of the areas of potential investment in our modularity section. So thank you for that.
Yeah, I think that's
Jen.
super important, and I'm excited to hear you say that. I'm interested a little bit on your thoughts. You mentioned that you do have the ability and interest in looking at how to consolidate treatment plants, but NAWI is specifically interested in kind of the reverse, more the decentralization. So what is your take? I mean, and that I think, and I know would inherently involve the horizontal assets, as you say, because some of the benefits are in that pumping, the underground pumping type stuff. But like, what are your thoughts on these kinds of tools to enable the reverse of consolidation?
Yeah, so Jen, I want to be clear, like, it's not my position or our position that we should consolidate or we shouldn't. It's
right.
whatever our clients need is what we push for or support. So in the case of United Utilities, they're thinking, hey, what if we consolidate? What does that look like? In the case of distributed treatment infrastructure, what's really cool is that we have companies that have developed modular treatment systems that perform phenomenally well in the field, and they have for quite some time, but they can't scale because they don't have the engineering teams to get their proposals in front of engineering firms that are the ones to basically propose those solutions into utilities. So most utilities, and this is a gross assumption here, but correct me if I'm wrong, most utilities lean on an engineering consulting firm to do that assessment for them, decentralized or not, What type of treatment technology are we going to use or not? Should we use a modular system? Should we use an MBR plant? Should we upgrade it? Right. If Karen, let's say Karen's equipment, she wanted to start doing municipal wastewater treatment, and it's decentralized. It's a modular system. Let's say it's a black box you put on site, and it can take in the influent from, I don't know, whatever, 100 households. Karen can't scale and deliver the number of proposals to those engineering firms she needs to do without hiring an army of engineers. So the way we think about it is, Karen, for this cost, the cost of one full-time proposal engineer, you can develop an unlimited number of them at any time that never get sick, right? People that don't get sick, the software doesn't get sick, and you can get your ideas or concepts out into the world at effectively low cost. That's how we think about that side of the equation.
Just want to do a little time check. We have 4 minutes left, and I appreciate that. Bhavna notes that that there's a next session coming up where you'll hear more about AI and ML opportunities from the research side of things. I also want to kind of say what I think that one practical follow-up, Adam, is I think that the Proteus Lib team will listen to this recording, and that'll be a great way for us to then set up some sort of interface where they can begin to kind of ask you questions as to what inputs are needed for your models, and then you could also guide them to what places are going to make things potentially compatible. Any final, I would encourage anybody else who's on the line, any other final comments or questions about the use of AI in design? Maybe I'll ask some final one, Adam, is that you, in the beginning, talked about, yes, AI is coming, it's transforming industries, et cetera. What isn't going to be tractable for this sort of approach?
So, super concrete example, detailed piping, interconnecting piping.
Why not?
HVAC is another good example. So
really?
That's totally. And the reason that is because there's conceptual design and then there's reality. So when an engineer walks on site and they talk to an operator, in theory, the operator goes, why in the hell are you putting the pipe here where I have to step over it so I can access this pump so I can serve it, maintain it appropriately? A conceptual design.
That's ergonomic. That's a workflow. I get that software might not be that good to kind of anticipate workflows and think about ergonomics for sure. Okay, so that's something that this will not do.
That's right.
Okay.
That's right. Yep.
Well, thank God there's something for the engineers to do.
So what we believe will happen is that engineering hours will be repurposed into what you said earlier, Peter, alternatives evaluation, more detail in the early stages of design. So yeah, I want shrubs, or I want to do an AR VR walkthrough, or I want to do a cloud point map and integrate that into my design, right? That's the stuff they're going to be doing. And our hope is that they'll also be out in the field. There's way too many process engineers, wicked smart, that sit behind a computer all day and never get out and see the stuff that's actually built. When they get out,
hear the real stories about,
yes.
Oh yeah, you guys, because I think that there's finally another, I was wonder if there's another thing that, it's one thing for somebody to say, a cocoa DAF filter sounds like a great thing. But when you go out and actually see the facility, you talk to the operator and she says, it's a piece of shite, to never constantly need to work on the filters. You guys can guess what country that analogy is from, but so I think that's where the practicality and user experience of the unit process diverges from what the model represents is another area where engineers are going to have to be needed, or experience is going to have to be needed, to essentially say, oh yeah, that's a slick assumption, but I don't think it works as well as you think it works. I do not think these are the droids you're looking for.
That's exactly right. Or we move, more downstream into the digital twin. And like what Warren's talking about, other folks talking about, like, what does sensorization of this look like? What sort of data are we going to pull off it? How do we analyze that data? They're probably going to become more data technicians and wizards than they are like design engineers or design wizards. I think it's going to move more into OT.
I think you're right. I think you're right. So those go long in that. If you are in engineering school right now, Civil Works is great, but go long on the controls, buddies, men and women out there. Right. All right, we've got to call it quits here. Brittany is pulling us back into our next session. Thank you all very much. Thank you so much, Adam. Adam, you have some follow-ups. We look forward to having your continued engagement in the NAWI program. Bye, everybody.
Thank you, everybody.
Thank you, everyone.
See ya.